Faster than the genuine surface of spacetime itself, it has the ability to remain aware of it. Consequently, it will persistently obliterate this thought, filling me with a growing sensation of burden. At this precise second, the night sky above is undergoing a rapid transformation. In the next few decades, or possibly even sooner, it could become completely unrecognizable. Leading experts, including Neil deGrasse Tyson, have sounded the alarm, recognizing the inevitable change brought about by the shifting position of Polaris. The changes behind this phenomenon are surprisingly unexpected. Polaris, commonly known as the North Star, has been a reliable celestial feature for centuries, serving as a key reference point for astronomers, navigators, and stargazers alike. However, this could soon change, altering the way we perceive the sky and how we explore the universe. For a long time, Polaris has been a guiding beacon for sailors and stargazers, remaining steadfast in the heavens. This dependable presence has been crucial for navigation, yet this stability may soon be disrupted. A paper released by the esteemed Royal Astronomical Society in September 2023 raised concerns about the future of this celestial marker. Polaris is entering a tumultuous phase, one in which it may explode and disappear from view forever, fundamentally altering the sky as we know it. Before considering the potential consequences of this event, we must first examine the characteristics of the star itself. Polaris stands out due to its position near the celestial North Pole, located directly above Earth's northernmost point. It appears almost stationary in the sky and is part of the Ursa Minor constellation, often referred to as the Little Dipper. Polaris emits a moderate degree of brightness and is classified as a yellow-white supergiant star. It is significantly larger and brighter than our Sun. However, Polaris is not just a single star. It is part of a complex triple star system composed of Polaris A and Polaris B as a binary pair, with a third star orbiting them. The gravitational interactions between these stars influence their orbits and behaviors. Any disturbances in these interactions could cause shifts in their brightness or pulsation patterns. Despite this, the exact nature of these forces is not yet fully understood. Polaris is located approximately 323 light-years from Earth, meaning the light we observe today actually began its journey centuries ago. If Polaris were to explode, its effects would not be visible to us for over 300 years. In fact, it is even possible that Polaris has already exploded, but we have yet to witness the consequences. Throughout history, the North Star has held immense cultural, navigational, and symbolic significance. Its unwavering position in the sky has made it an invaluable guide for ancient sailors navigating vast oceans and lands. Symbolically, Polaris has represented stability and direction, remaining unchanged in the ever-shifting sky. For astronomers, Polaris has served as a vital reference point in the study of stellar movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have provided crucial insights into the properties of stars and the behavior of variable stars. This characteristic has also been instrumental in measuring cosmic distances and calibrating scientific instruments. Since its pulsations follow a predictable pattern, its behavior has traditionally been relatively easy to predict. However, in recent years, Polaris has begun to show signs of deviating from its usual behavior. This anomaly in its pulsation cycle has drawn the attention of astronomers, prompting further investigations into the cause of these unexpected changes. Rather than following its typical rhythm, Polaris has started to exhibit irregular dimming, raising concerns that the star may be nearing the end of its life cycle. This behavior aligns with patterns observed in stars approaching their final stages. The steady increase in Polaris's pulsation period, which was once constant, has been traced back to interactions within its star system. Over the past year, there has been an annual increase of around 4.5 seconds in the pulsation period. While this may seem like a minor change, it holds significant implications. Some astronomers suggest that the gravitational forces within the Polaris system could be driving these changes, directly affecting its atmospheric conditions and pulsation patterns. Others are more concerned that Polaris is entering a critical phase that could lead to an explosion. The similarities between Polaris's behavior and that of Betelgeuse, a prominent star in the Orion constellation, are striking. Both stars have exhibited complex variations in brightness, leading to concerns that they may be nearing a catastrophic explosion. Stars nearing the end of their life cycles often display such irregularities before their demise. NASA has expressed greater concern over Betelgeuse, but formal attention has yet to be fully directed toward Polaris. As a Cepheid variable star approaches the end of its life, it goes through several stages, including the red giant phase, ultimately culminating in a supernova explosion. Given the irregular pulsations observed in Polaris, scientists speculate that it has entered the phase of helium depletion, which is typical for giant stars nearing the end of their lives. These irregularities align with patterns seen in other stars in their final stages. However, conclusive evidence of an impending supernova remains uncertain, and astronomers continue to monitor these phenomena to better understand the fate of Polaris. If Polaris were to undergo a supernova explosion, it would be a spectacular event in the sky, possibly outshining the moon and remaining visible for days, weeks, or even months. Its brightness could dramatically alter our perception of key celestial bodies, such as the Big Dipper, Ursa Major, in which Polaris plays a significant role. Fortunately, Earth would likely remain unharmed by such an event due to Polaris's immense distance from us. While the explosion of Polaris might not be as visually dramatic as that of Betelgeuse, it could still be visible to the naked eye for an extended period, surpassing nearby stars in brightness. This would undoubtedly capture the attention of astronomers and observatories, sparking widespread interest both in the academic community and among stargazers. However, the impact on Earth's environment or ecosystems would be minimal compared to a supernova occurring closer to our planet. Now, let's turn our focus to what will happen to Polaris itself in the aftermath of a potential supernova explosion. It's essential to understand that while massive stars generally end their lives in a supernova, this is unlikely for Polaris. When a massive star undergoes a supernova, its core collapses, triggering a violent shock wave that causes the star to implode. However, Polaris is not massive enough to experience such an extreme event. Instead, once it exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transformation will not result in a supernova but will mark a quieter end as Polaris evolves into a small, incredibly dense stellar remnant. A white dwarf is the compact core of a low to medium-mass star that has burned through its nuclear fuel. Despite its small size, roughly that of Earth, it will still contain the mass of the Sun. Once this transformation occurs, we will no longer see Polaris as we do today. As it transitions into a white dwarf, its brightness will gradually fade, making it less discernible in the night sky. Over time, it will cool and dim, eventually becoming a faint and nearly invisible stellar remnant. This marks the final stage in the life cycle of many medium-mass stars, a fate that awaits Polaris in the distant future. The disappearance or transformation of Polaris will have profound implications both scientifically and culturally. For centuries, Polaris has served as a fixed point in the sky, guiding travelers, astronomers, and navigators. Its absence or reduced brightness would alter traditional celestial navigation, requiring future generations to rely on different reference stars or advanced technological solutions for orientation. Beyond its practical significance, Polaris has held deep symbolic meaning across civilizations. In mythology, literature, and philosophy, it has represented stability, guidance, and unwavering direction. The potential changes to Polaris challenge these long-held associations, reminding us that even the most seemingly eternal celestial bodies are subject to the relentless forces of cosmic evolution. For astronomers, the evolution of Polaris presents a unique opportunity to study stellar life cycles in real time. By closely monitoring its behavior, scientists can gain valuable insights into the processes governing Cepheid variable stars, stellar aging, and the eventual fate of stars similar to our Sun. This ongoing research may also help refine our understanding of supernova mechanisms, stellar pulsation, and the interactions within multi-star systems. Looking ahead, the night sky will continue to evolve. As Polaris gradually transforms, other stars may take its place as guiding beacons. In approximately 12,000 years, due to Earth's axial precession, Vega, another bright star, will become the new North Star. This recurring change in celestial positions highlights the dynamic nature of the universe and the perpetual motion of the cosmos. While the transformation of Polaris may seem unsettling, it serves as a reminder that change is a natural part of the universe. Stars are born, live, and eventually fade away, contributing to the ongoing cycle of cosmic renewal. The atoms that make up Polaris will one day disperse into space, potentially forming new stars, planets, and even life. The transformation of Polaris is part of a larger cosmic story, a reminder that the universe is constantly in motion, evolving over millions and billions of years. As Polaris enters its final stages of life, its fate reflects the natural progression of all stars. This knowledge enriches our understanding of stellar evolution and the interconnectedness of cosmic events. As humanity looks to the stars for exploration and inspiration, the eventual changes to Polaris will likely spark renewed interest in astronomy. Future generations of astronomers may use advanced telescopes and technologies to study the remnants of Polaris, examining its transition to a white dwarf in unprecedented detail. This could lead to breakthroughs in our understanding of how stars like Polaris contribute to the formation of new celestial systems. Culturally, the disappearance of Polaris as the North Star will mark the end of an era. However, it will also signify the beginning of a new one, as Vega and other stars take on the role of celestial guideposts. As Earth's axis continues to shift over millennia, humanity will adapt, creating new myths, symbols, and navigational practices to reflect the changing sky. Moreover, the study of Polaris and other variable stars will remain crucial in understanding the distances and dynamics of the universe. Cepheid variable stars like Polaris serve as cosmic yardsticks, allowing astronomers to measure vast distances in space. Even as Polaris fades from its prominent position in the night sky, its legacy will endure in the science it has helped to advance. The fate of Polaris also offers a powerful perspective on the transient nature of existence. Stars, planets, and even galaxies are not eternal. They are born, they evolve, and they eventually fade away. Yet, through their life cycles, they contribute to the creation of new cosmic structures, perpetuating the cycle of life in the universe. In the meantime, we can continue to appreciate Polaris as a steadfast beacon in the night sky. It remains a symbol of constancy and direction, even as its eventual transformation looms in the distant future. Its story reminds us of the vastness of the cosmos and our place within it, a small but interconnected part of an ever-changing universe.